Let's take a look at a few more of these distribution problems. And for the very first question, I notice that there's a power of 2 here. So we can use the square double square technique. So basically how that technique works is you take your first term, which is 4x, and then you want to square that, which is going to be 4x times 4x, which is going to be 16x squared. And then you want to multiply 4x and 1, which gives you 4x. And if you double that by timesing that by 2, you get 8x. And then your last term here is a positive 1. So if you square the positive 1, you just get a positive 1 there. Okay, so how does this apply? Basically, you write your coefficient of 5. And then since you use the square double square technique, you would write out 16x squared plus the 8x plus the 1. So that right there is the square double square technique. And then after that, you would just distribute this. So the 5 would now distribute into everything in the bracket. So 5 times 16 is going to be 80x squared plus, and 5 times 8 is going to be 40x. And then finally, 5 times 1 is going to be positive 5. And there's your answer for the very first question. Okay, moving on to the next one here. All right, so this question here, we can't use the square double square technique. We just need to distribute using FOIL. So we do this a few times here. So x times x gives you x squared. And then x times negative 6 will give you negative 6x. And then on the inside here, negative 3 times x will give you negative 3x. And then negative 3 times negative 6 will give you positive 18. Okay. All right, then we have a plus sign here, and then we can just distribute the other side now. So x times x is x squared. X times 7 is going to be positive 7x. And then on the inside here, 2 times x is going to be positive 2x. And then 2 times 7 will be positive 14. All right, so from there on, you want to just collect like terms here. So there's an x squared and a positive x squared. So x squared plus x squared will be 2x squared. Okay. And then if I just combine this right here, negative 6 minus negative 6 minus 3x will be negative 9x. And then plus the 18. And then I have a positive 9x over there. And then I have a positive 14. And then it turns out that I have a negative 9x here and a positive 9x there. So those two terms will essentially cancel. And then we have 18 plus 14, which will be 32. So my final answer is 2x squared plus 32. Okay, so we're just collecting like terms there to finish off that question. Let's take a look at the next question here. And for the next question, there's quite a bit going on here. There's a 9 to lead off the question. There's also a negative 2 there. And it might be a good idea to maybe FOIL out the brackets first, collect like terms, and then deal with that 9 and that negative 2 at the very, very end. Okay, so x times x here will be x squared. And then x times positive 7 will be positive 7x. Negative 1 times x will be negative x. And then negative 1 times 7 will be negative 7. And then it might be a good idea just to put that in a bracket there. And then we still have the negative 2 and the 9 hanging around. Okay, and after that, there's a plus sign here, so we'll include the plus. And then let's go ahead and just distribute these brackets now. So 2x times x will be 2x squared. 2x times negative 3 will be negative 6x. Negative 5 times x will be negative 5x. And negative 5 times negative 3 will be positive 15. Okay, from there on, before we start collecting or distributing more here, it might be a good idea to just collect like terms here inside the brackets. So a negative 7x plus x, we can definitely collect like terms there. And that will be positive 6x. And that will be a minus 7 at the very end there. Plus, I have my 2x squared. And then we can also combine the negative 6x and the negative 5x, which will give you negative 11x plus the 15. Okay, this is looking pretty good here. Let's highlight the negative 2 here. And now this negative 2 will now distribute into the brackets here. So that will give me negative 2x squared. Negative 2 times positive 6x will be negative 12x. And then negative 2 times negative 7 will be positive 14. Okay, and then we can just add on the rest here. And then finally, we also have a 9 that's leading off the problem as well. Okay, so that takes care of most of the heavy lifting now. What you want to do now is collect like terms as possible here. So I know this negative 2x squared and this positive 2x squared, that will definitely cancel out. and then we have a negative 12x and a negative 11x. So if I combine those, we'll get negative 23x. And then finally, if I take my 14 plus my 15, I guess that would be 29. 29 plus 9 will be positive 38. All right, so a lot of collecting like terms at the very end of that problem to finish off. Okay, let's keep on going with a few more of these distribution questions here. Okay, so now we can use the square double square technique again. So there's a power 2 there. So if you want to use the square double square technique, you take your first term, which is y, and you square it. So y times y is y squared. And then you multiply the you multiply the y and the negative 1, and you get negative y. And if you double that, you times that by 2, which is minus 2y. And then finally, you have the negative 1, and you just square that. So negative 1 times negative 1 and will be positive 1. And that's how you can quickly do the square double square technique for that problem, for that part of the problem. And then you have your minus 2 there. And then you have a power 2 over here as well, right? So you want to square double square that as well. So if I take my 2y squared will be 2y times 2y, which is 4y squared. And then you multiply the 2y and the negative 1, which gives you negative 2y. If you double that, you get negative 4y. And then finally, when you have your negative 1, if you square the negative 1 times negative 1 is positive 1. And that's how you can do the square double square technique for that part of the problem. Okay, from here on now you want to distribute this. So that will be 3y squared, and 3 times negative 2y will be negative 6y, and then 3 times positive 1 will be positive 3. If I distribute this now, negative 2 times 4y squared will be negative 8y squared. Negative 2 times, so once again, you're taking your negative 2 and you're multiplying by negative 4y, and that'll give you positive 8y. And then negative 2 times positive 1 will be negative 2. Okay, so that's looking pretty good there. And then from here on, you want to collect like terms here. So I have my 3y squared and my negative 8y squared. So 3 minus 8 will give me negative 5y squared. Okay, once you're done with that, you can cross those off. Then I have a negative 6y and a positive 8y. That'll be positive 2y. And once you're done with that, you can cancel that off. And finally, you have a positive 3 and a negative 2. So 3 minus 2 will be positive 1. And there's your answer there, negative 5y squared plus 2y plus 1. Okay, let's keep on going with a few more of these distribution questions here. So now we need to apply the square double square technique 2 times here. Okay, so let's go ahead and do that. If I square the 2x, that's 2x times 2x, which is 4x squared. Okay, and then if I multiply the 2x and the 3, I get 6x. And if I double that, I get positive 12x. And then finally, if I have a 3 there, if I square that, 3 times 3 is positive 9. All right, so that's how you take care of that first bracket. So basically, this first bracket is done. Let's go ahead and square double square the second bracket. So if I take my negative 2, if I square that, I get 2x times 2x, which is 4x squared. 2x times negative 3 will be negative 6x. And if I double that by timesing by 2, I get negative 12x. And then finally, at the very end here, I have my negative 3, and we square that. So negative 3 times negative 3 will be positive 9. Okay. All right, so this is kind of a longer problem now. We need to apply FOIL here in a way. So let's go ahead and do that. So you take your 4x squared and times by your 4x squared. And if you do that, you get 16x to the power of 4, right? And then your 4x squared. Let me just erase that. And then you take this 4x squared and multiply with your negative 12x. So 4 times negative 12 will be negative 48. And this will be x to the power of 3. Okay, and then finally you take your 4x squared and multiply with the last term here. So 4 times 9 will be positive 36x squared. And that takes care of the 4x squared. And then you take a look at your 12x, and now you start distributing this. So 12x times 4x squared will be positive 48x cubed. And then 12x times negative 12x will be negative 144x squared. And then 12x times positive 9 will be, I guess 108x. and that takes care of the 12x. And then finally, kind of to keep on going here, then we look at our last term here, which is the positive 9. And now we start distributing this now. So 4 times 9 will be positive 36x squared. And then 9 times negative 12 would be another negative 108x. And then a 9 times positive 9 will be positive 81. Okay, so let's see what we can come up with all of this. Now we're going to collect like terms, right? So one thing that I see right away is there's a positive 108x and a negative 108x. So that can definitely cancel off. Then I see a positive 36x squared and another positive 36x squared. So I guess we can combine those. Let's see if we can cancel off anything else here. So I have a negative 48x cubed and a negative 48x cubed. Those can definitely cancel off. Okay, let's go ahead and finish off this problem here by collecting all the like terms here. So I have 16x to the power of 4. If I combine this and this, I guess I get positive 72x squared, and then I can minus the 144x squared, and I have my positive 81 at the very end. And then one final thing we can do here is we can combine these like terms, and that will give me 16x to the power of 4 minus 72x squared plus 81. All right, so there's a lot going on in that particular question. You have to be very good at collecting all the like terms, and that's a very good question. Let's move on to the next distribution question here. And for this problem, we have 3 binomials being multiplied with each other. It might be good to kind of multiply the first 2 terms together here. So if I apply FOIL here, I get x times x, which is x squared. And then x times negative 2 is negative 2x. And then negative 1 times x is negative x. And negative 1 times negative 2 is positive 2. And then we'll have our bracket here of x minus 3. And then before we distribute this, it might be a very good idea just to collect like terms. So if I collect the like terms there, I get x squared minus 3x plus 2. And then I have my other brackets of x minus 3. Okay, so now we're ready to distribute this one last time here. So it's first times first now. So x squared times x is x cubed. And x squared times negative 3 will be negative 3x squared. Okay, so that's done. And then we take a look at our negative 3 now, and our negative 3 will multiply with this x, which is negative 3x squared. And then this negative 3 times the negative 3x times the negative 3 will be positive 9x. So that's done. And then let's highlight the positive 2 here, and the positive 2 times this x will give you positive 2x. And then 2 times the negative 3 will be negative 6. Okay, and finally, with most of these problems, we now have to collect like terms here. So I have my x cubed. There's no other like terms with the x cubed, so that goes away. I can definitely combine these two terms. So negative 3 minus 3 will be negative 6x squared. So those are now done. And then I have 9x plus 2x, which will be 11x, and then the minus the 6. Right, so these are some very good distribution questions where you have to be very good at foiling or square, double square, or just distribution in general, and just be very careful with your with collecting the like terms at the very end. Okay, let's move on to the next. Let's move on to the next binomial multiplication question here, and this is a very unique question here where I have 2017 squared minus all of this. And you can definitely do this question without using a calculator here. And the trick is that you have a 2017 here, and you want to use that number to kind of recreate these two numbers over here. Okay, so I have my 2017 squared minus, okay, so I have a 2015 here. What we're going to do here is we're going to use a 2017. And what do I have to do to 2017 to get to 2015? Well, I need to subtract 2. Okay, so what we're trying to say here is that this expression right here is equal to the 2015 there in blue. Okay, and then if I take a look at the 2019, I want to rewrite this using a 2017. So let's go ahead and write down 2017, And what do I need to do to 2017 to get back to a 2019? Well, you just need to add a 2 there. Okay, and this is going to work out really nicely now because what's going to happen over here, if you actually FOIL this out, you'll get a very nice expression here. So let's go ahead and see if we can FOIL that out. Okay, so 2017 times 2017, well, that's going to be 2017 squared. Okay, and then if I go 2017 times positive 2, that'll be positive 2 times 2017. And then on the inside here, I get negative 2 times 2017. And finally, I have a negative 2 times negative 2 times positive 2, which is negative 4. Okay, and then you'll notice that these two terms right here in green, they just cancel out, right? Because you're adding 2 and subtracting 2, so those just cancel out. And then if you keep on going here, you get 2017 squared minus the 2017 squared, and then this minus sign times this minus sign will give you positive 4. Okay, and then you'll notice that these two terms here, they just cancel out, giving you just the positive 4 there. All right, so that's a very nice question that you can try without using your calculator. A little bit of foiling, and you'll notice that everything cancels out nicely. Okay, let's keep on going. Next question here. Given that for every value of x, we have x squared minus 10x plus 39 equals to this. Okay, in order to do this question here, you want to expand that. So if you had to expand this, for sure you can use the square double square technique if you like. I'll just expand this using straight up FOIL here. So I get x squared minus ax minus another ax, and then a negative a times a negative a would be positive a squared plus the b. And then if I erase all that, if I go ahead and collect like terms here, that gives me negative 2ax. And then I have my x squared there plus my a squared plus the b. Okay, so that's what happens if you just collect like terms and expand that. And we're saying that that expression here, this expression right here, is equal to this expression right there. Okay, so what I'm going to do now is I'm just going to rewrite the x squared minus 10x plus 39 underneath this. And let's just make some careful observations here. You should notice that this x squared and this x squared, they're equal, right? Then you should also notice that this negative 2ax and this 10x, I mean, they're kind of lined up to be equal, right? So what you can conclude from that is you can say that negative 2ax has to equal to your negative 10x. Okay, just by looking at that algebraically, you can see that the x's just cancel off, and then you have your negative 2a equals to negative 10. And then if you divide both sides by negative 2 and that by negative 2, you end up getting a, which equals to positive 5. Okay, so a equals to positive 5. And then if you keep on going here, if I use a red marker here, we know that this has to be equal to each other, right? So if we keep on going along with this math problem, a squared plus b has to equal to your 39, right? So you make your last terms equal to your last terms. And we know that a is already 5, so 5 times 5 will be 25 plus b equals to 39. And then if you want to solve for b, you need to subtract 25 from both sides. And we get b would equal to positive 14. Okay, so that's a great question there. You do quite a bit of those kind of questions in senior level math. Question: we have a right triangle, and the lengths of the sides are all integers. So if we're labeling this triangle, I guess we can say this is A, this is B, and this is C. And if we're using the Pythagorean theorem here, I guess we can now write a squared plus b squared equals to c squared. Now this question also tells you that the hypotenuse and one other side is 49. Okay, so if I take a look at the hypotenuse, which is c, I need to grab one other side. So let's go ahead and grab this side over here. So we're saying that c plus b equals to 49. Okay, and if I go ahead and solve for b here, I can solve for b by subtracting c from both sides. And if I solve for b now, b would equal to 49 minus the c. Okay, so what we're going to do here now is I'm going to erase this b over here, and I'm going to write 49 minus c. Okay, now if I go ahead and just, sorry, that didn't really come out great here, so let me see if I can rewrite that. So this is 49 minus the c. Okay, so if I go ahead and apply the Pythagorean theorem now, so I have my a squared, so that will be a squared. And now my b has turned into 49 minus c, right? So I can write this as bracket 49 minus c, all to the power 2 equals to c squared. All right, so great. Now we have another one of these kind of problems where we need to FOIL this out using the square double square technique, or we can just write it out as 49 minus c times 49 minus c equals to c squared. Okay, so let's go ahead and FOIL this out here. So I have 49 times 49, which is going to be, so 49 times 49 is 2,401. And then you have your 49 times negative c, which would be negative 49c. And then we have another negative 49c. And then c, negative c times negative c is going to be positive c squared. And that would equal to c squared on the right-hand side over there. All right, so a lot of foiling and distribution, collecting like terms, things like that in this homework here. So let's go ahead and keep on collecting like terms here. So I have 2,401. And then if I just combine these two terms, I get negative 98c. And then turns out that this c squared and that c squared, they just cancel out. So this is going to equal to basically 0 on the right-hand side. Okay, so what we're going to do now is we're going to take our negative 98 and we're going to move that to the right-hand side. If I move that to the right-hand side, I get positive 98c. If I take this 2,401, if I move that to the other side, I get negative 2,401. And then I have the a squared over here. Okay, so this is a bit tricky here. All right, so what we're going to do next here is doing a little bit of math here. You can actually factor out a 49 from this. If you factor out a 49, you'll get 2c minus 49. And I can kind of see that because I know this actually came from, 49 times 49, and this is really 2 times 49. So I can just easily take out the 49s to be my greatest common factor there. Now, if you have a power of 2 here, what we're trying to say here is in order for this to give you an integer, you want this whole expression here on the left here to be a perfect square. Okay, so a perfect square, for example, if you had to take the square root of that, this would give you 7, right? And then this part right here, the 2c minus 49, this has to give you a perfect square. Okay. So this is the hard part of the question here because that part of the problem here, the 2c minus 49, has to be a perfect square. So what you can do is you can take your 2c minus your 49 and you can make it equal to a perfect square. All right, so what are your perfect squares out there? I mean, the first one is going to be a 1. It's a perfect square. 1 times 1 is 1, and then 2 times 2 is 4, 3 times 3 is 9, and 4 times 4 is 16, and 5 times 5 is 25, right? So these are some of the perfect squares that are out there, and you want to test all of these to make sure that you get a nice integer value for c there. So if I go ahead and test the 1 here, let's go ahead and solve for the 2c now. So I get 2c equals, and then the negative 49 can bring over as 1 plus 49. 2c would now equal to 50, and c would equal to 25. So this is one answer that works, so c would equal to 25. Okay. Now that I'm done with the 1, let's just go ahead and try the 4 now. Let's see if the 4 works. So basically what we do the math here, this will be the 4 here. Let's just test if this works now, right? So we have 49 plus 4, which equals to, so 2c would equal to 53. And then if you divide both sides by 2, 53 divided by 2 gives you 13.25. So this is not an integer, so 4 does not work. So we cancel all this. And we conclude that the 4 does not work. Let's try the next perfect square, which is 9, and hopefully we get a nice integer for c here. So I get 2c would equal to 9 plus 49. So 9 plus 49 is going to be 58. And then you can divide both sides by 2, so 58 divided by 2 gives you 29 for c. So it turns out that c would equal to 29. That's another answer that works. So now we can say that the 9 is done. And then we kind of repeat the process until we're done all our choices here. Our next perfect square is 16. And let's just see if we get a integer for 16, which is a perfect square. So 16 plus 49 gives you 65. And I know that that won't give me an integer if I divide by 2, so the 16 does not work. And then let's try 25 at the very end here. Let's try 25 over here. So now we have 25 plus 49 gives you 2c equals to 74. And if I divide both sides by 2, I get c equals to 37. Okay, so these are some combinations that work. I mean, we can test a few more numbers here, but we'll stop at 3 because then we'd be here for a little bit while there. But these are 3 numbers that work for this particular question.